Good morning, I'm the Human Resource Coordinator of the company Integral Corporation. Today I will be interviewing 5 people as we need a new math professor. My main concern is whether they can explain and apply definite integrals.
So like integrals, like derivatives.
Julia, next.
Integration can be used to find the areas, volumes, and many useful things, but it is mainly used to find the area under the graph, which is like this. And basically an integral is a reverse of a derivative, and the rules of integration can help you to get the answer for this. And the symbol of integration is basically an S, and then the function which you want to integrate, which is also known as the integrand.
Integrals have an interesting economic and business application. For example, they are used for computing consumer and producer surplus, the total profit, cost, or revenue from the marginal profit, and frequently they are used for finance and compute the present value of continuous stream of money.
This formula is called the definite integral of f of x on the interval a and b. The number a is the lower limit of integration and the number b is the upper limit of integration. Considering the formula is continuous and bigger or equal than 0 on the interval a to b, then the formula gives us the area of the region below the function and the x-axis from a to b. To calculate the given function, we firstly need to make the integral, which is the antiderivative, and then we need to plug in a and b and make the difference between them.
So now we will try to solve a basic integration problem, and like we said before, integration is the reverse of derivatives, and the limits we will have today are 0 and 2, and the equation is x to the third minus 2x5 plus x plus 2 dx. So the first step is to integrate the equation, and to do so we're going to use the power rule, which for example means if I have x to the power of 2, it will become x to the power of 3 over 3. This is the power rule. It can be used by any exponent except -1. And coming back to our equation, we had x3, so it will become x to the 4 over 4 minus 2x to the power of 6 over 6 plus x squared over 2, and because we had 2, which is a constant, it had no x, so we're going to add an x to the 2, which will become plus 2x, and of course dx at the end. We should never forget dx at the end. Earlier you could see that we had minus 2x to the power of 6 over 6, and minus 2x is going to be simplified to minus 1/3, and what we're going to do now is 2 to the power of 6, which is 64, times -1 is minus 64, it will give us minus 64 over 3, so we have 4 minus 64 over 3 plus 2 squared over 2, which is really simple, it's 2, and finally 2 times 2 gives us 4, and all of this we should subtract it by the other equation, and instead of writing it, it's going to be simple, as we have 0 as a limit, the equation will equal to 0, so all of this we're going to subtract 0 from it, so technically all we're going to do is solve this equation. So 4 plus 2 gives us 10, and since we have 64 over 3 plus 10, we don't have a common denominator, so what we're going to do, as our beloved teacher taught us, we're going to find the common denominator, and we will do this by multiplying by 3, and when you multiply 10 by 3 you get 30, and minus 64 plus 30, and since we are finding the area, of course the answer will be positive 34 over 3.
Okay, so now I'm going to explain to you what's the u substitute rule. So here you have this function with this integral. So now you just need to find what's the u value. So here it's x to the power of 4 plus 5. And then you need to find the derivative of this, so it's 4x to the power of 3, and so the derivative helps to cancel out this. So this can also be written like this, u to the power of 3 du. So now you do the power rule. So you have u to the power 4 over 4, and you also put the integrals, and now you just plug in the u value. So it gives you x to the power 4 plus 5, this at the power 4 over 4, and you put the integrals. Okay. Now you just plug in into this the limits. So you start by the bigger one, so it's 1, and it gives you 1296 over 4, and then you take out the value for the zero limit, and this one is 625 over 4. So the final result is 671 over 4. So now you just plug in the limits of the function. So first, if you start with the bigger one, the one on the top, it's 1, and that gives you 1296 over 4, and then you take out the value of this with the zero value, and that's 625 over 4, and that gives you the final result, that is 671 over 4.
As you can see in the graph, we have two shaded areas. The purple shaded area is the consumer surplus, and the yellow shaded area is the producer surplus. And you can be wondering what's the point in the middle. And so the point in the middle is simply where they both intersect. It's where demand equals supply. This is what we call the equilibrium point. And the point has two coordinates, and to find them we do something really simple. We equal the two equations, so we'll have 10q plus 500, our demand equation, equals to minus 50q plus 2000, which will give us q equals 25, and after we choose which equation we want, and we plug the 25, and our final answer, we got that p equals $750. So the coordinates of the equilibrium point are 25, 750. So the two examples we're going to use involve the demand function and the supply function, as I said, that are given to us. So our demand function, which has always a negative slope because no one will be willing to pay at a higher price, is p equals minus 50q plus 2000. And the supply function, it's p equals 10q plus 50, and of course the slope is always positive and rising, and the supply function is used to determine at what units a producer would supply at a given price. So to find out the producer and consumer surplus, what you can do is integrate both equations, and to do so and to find the area, we need to use our definite integrals, and of course this is where our integration plays part. So the equation is going to be simple for both equations. We're gonna have the integral, and the limits are going to be the x-coordinate at the right edge and the x-coordinate of the left edge, and in the middle of the equation we're going to have the upper function minus the lower function, and of course we should never forget our dx. And to find the producer surplus, we're going to do the opposite, which is using the supply function instead of the demand function, and it is 10q plus 500. And of course we have the same limit, 0 to 25, but this time the 750, in other words our equilibrium price, goes to the left. We're going to subtract 750 minus 10q plus 500, and the limits stay the same as I said. So when we integrate, we will have 750q minus 5q to the power of 2 minus 5q, and when we replace the first limit and subtract it by the answer we get in the second limit by replacing 0, of course we get $3,125, which in turn translates in our producer surplus. And to find the equilibrium point, there is one way we can find it, and just to set the two equations equal to each other, the supply and the demand equation, which will give us 2 points. So 10q plus 500 equals minus 50 plus 2000, and it will give us q equals 25, and then we're going to plug 25 in one of the two equations we choose to, which will give us 750, and 25, 750, it will be our point, and of course the equilibrium point is where demand meets supply.
Oh, so many great characters, I do not know who to choose.